Hello, this is question 13 on your mixed exercise 14. The radioactive decay of a substance is modeled by this formula. So we have an exponential is r equal to 140 e to the power of kt. T is greater or equal than 0, where r is a measure of radioactivity in counts per minute at time t days and k is a constant. Explain briefly why k must be negative. This is because it says is decay, yeah? So it means the radioactivity must decrease with time. If it must decrease, our graph needs to be doing something like this. It's an exponential, but with the this value negative, yeah? And I would just say because it's decay, so it's representing decay, so it must decrease. So it should, so R should decrease with time. Decrease with time. That means K must be negative with time. Therefore, K must be negative, yeah? B, sketch the graph of R against T. So we say it's going to be decreasing. This is B, this is R, this is T, and it's going to do something like this. We are able to find this value because this value, and we shouldn't represent anything before 0 because t cannot be negative, yeah? Is the time. And if we look at the model, when t is 0, so our y-intercept, when t is 0, this is 1, so r is 140. Yeah, when t is 0, r is 140. So we should write this number here. It's the only thing that we can add to the drawing, yeah? And then for C, after 30 days, the radiation is measured at 70 counts per minute. So R is 70 when T is 30. We have to show that K, this constant here, can be written as another constant, ln 2, giving the value of R. Yeah? So we are going to substitute in our formula when T is 30 days, R is 70. 70. 30 days? Yeah, when that. So if we substitute in the formula, we have that R is 70. So I have 70 is going to be equal to 140 times e to the power of k times 30. So I'm going to write the 30 at the front, 30k, yeah? We then, if we divide by 70, we have if we divide everything by 140, sorry, we have 1/2 is e to the power of 30k, and then we are going to take ln, yeah? Ln 1/2 is ln, ln 1/2 is going to be ln e to the power of 30k, which means ln 1/2 is going to be 30k, yeah? And we have to make k the subject and write it in terms of ln 2. We have ln 1/2, but it's going to be very easy to do that. So we can say that k is 1/30 ln, and instead of 1/2, I'm going to bring this into the numerator, yeah, as 2 to the power of -1, because that is going to help us, yeah? Or actually without brackets. 2 to the power of -1. Properties of the logs. This exponent can go to the front, and then I will have only ln 2. So I will have k is -1/30 ln 2. Yeah, so we have the expression, and that means that c would be -1/30 because they ask us to find that c, yeah, that c at the front of ln, yeah? And that's all with this question.